everyone! I'd like to talk to you about our paper. It's called The StoryTeller, Scalable, Building and Access Point Independent Deep Learning Based Floor Prediction. I am Rizanne Elbakly, and this is a joint work with my advisor Moustafa Youssef. So, what exactly is the StoryTeller? The StoryTeller is a system for floor ID estimation. It uses Wi-Fi access points detected by the user's device and deep learning and provides trained models that generalize well and are reusable across buildings. We were motivated to do this work because indoor location-based services require accurate location estimates, and most current systems focus only on 2D localization. However, indoor environments are typically multi-floor buildings, and a lot of applications like E911 and 3D navigation require accurate floor ID estimation. At the same time, deep learning has recently experienced a comeback because large data sets and the necessary computing power are now available. So we chose to work on floor ID estimation using Wi-Fi access points and deep learning. Of course, there exist systems that attempt the floor ID estimation problem. For example, sensor-based systems that use the inertial measurement unit and/or the barometer. However, these systems suffer from issues such as sensor drift and calibration issues, and are not available to all users. The second category of related work is 3D fingerprinting. This technique can provide very accurate results, but has very high deployment and maintenance cost, which increases the higher the building and the larger its area. In addition, 3D fingerprinting systems are tailored for a specific building and cannot be reused for new buildings. To handle shortcomings in existing systems, we proposed the StoryTeller. The StoryTeller uses Wi-Fi access points and deep learning to predict the user's floor. As you can see in the image sequence below, first, Wi-Fi access points detected by the user's device are converted to an image. Colors in this image depend on signal strengths of the access points. The higher the signal strengths, the brighter the color, and vice versa. Then, a deep convolutional neural network is trained to predict floor ID based on input images. The trained models can then be used for real-time floor prediction. In addition, trained models are reusable and generalized to any building. This generalization of the model is mainly achieved through the novel virtual building concept we propose, which makes the model building independent. Essentially, we transfer the problem to a virtual building that will have the exact same number of floors and exact same footprint, regardless of number of floors and area of the actual building. Now let's move on to the full architecture of the StoryTeller. We have the input, which is a list of currently detected Wi-Fi access points and their signal strengths. First, during pre-processing, the problem is transferred to the virtual building to make it independent from the actual building. Then, the Wi-Fi scan is converted to an image. Then, this image is fed to the trained deep convolutional neural network, which is a VGG19-based neural network, and the floor ID estimate is generated. Finally, we have a post-processing step that converts the output of the classification step to a floor number that is valid across the actual building, since the solution was actually made in the virtual building. Now let's move on to the evaluation of the system. We used two large data sets comprising 3 buildings to evaluate our system. Data was collected by more than 20 users, and the buildings have different properties. Here we compare our system to multiple state-of-the-art systems. As you can see, the StoryTeller on the far left has an error CDF that outperforms other systems by at least 38%. To test the generalization ability of the StoryTeller, we use combinations of trained test data from different buildings. We have 3 test buildings, indicated by the labels of each cluster, and different trained buildings. The last column is reserved for the best state-of-the-art system. As the figure shows, for all 3 test buildings, first of all, correct estimation of the StoryTeller is better than the state-of-the-art. In addition, StoryTeller has consistent performance within one floor error, even when using different trained data from different buildings other than the test building. Finally, the best other system is not consistent for the different test beds, as opposed to StoryTeller, which shows consistent performance. That's it actually. Thank you for your attention.